Okay, so this is moment of a couple. So if we have a force F, and that same force F but in the opposite direction, so that it's negative F, and the perpendicular distance between the two of them is D. Okay, so a couple is defined as two parallel forces that have the same magnitude but opposite directions and are separated by a perpendicular distance D. So a couple is defined as two parallel forces that have the same magnitude but opposite directions. And are separated by a perpendicular distance D. Okay? And that couple will produce a couple moment. Okay, so say you have point O, and you've got your negative F and your positive F. Now, if you had RA going to negative F and RB going to the positive F, and the perpendicular distance between those two would be R. Okay? So you can see here that you have RA plus R equal to RB. Or you can also write that as RB minus RA is equal to R. Okay? So if we were trying to find the moment of these two forces, if we're trying to find the moment of these two forces, we would do M is equal to RB cross F plus RA cross negative F. Okay? And then we could combine RB and RA using the distributive law. So RB minus RA cross F. And we know that RB minus RA is equal to R. So we just get R cross F. So what's interesting about couples is that M is a free vector. It can act at any points since M depends only on the position vector R. Directed between the forces and not the position vectors. RA and RB. So we see here that the moment is only dependent on R between the two forces. So what's this saying is that the moment is a free vector. It's acting anywhere. You can choose a point over here, A or B or whatever point. The moment is going to be the same around this point as it was at O. Because it doesn't matter what point you're doing, you're still going to have a RA going to it, an RB, and this distance R between the forces is going to stay the same. So your moment will be the same. So in scalar formation, it's that the moment is equal to the force times the distance between the two forces. And in vector notation, it's that the moment is equal to R cross F. And equivalent couples produce a moment with the same magnitude and direction. Oops. So that's like saying if you had a force of 30 and a distance of 4 meters, you would have a moment of 120. But let's say you had a force of 40 and a distance of 3 meters, you would get 100 and you would still get 120. So it's an equivalent couple. And then we can find a resultant couple moment by adding each force's moments. So it's the same as any other moment. The resultant moment will be the sum of your position vector across your force.